In this episode, we're going to make AI asset inventory feel like one of the most practical, confidence-building parts of AI security management, even though the word inventory can sound boring at first. A surprising number of security problems happen because organizations do not know what they have, what is connected to what, or who owns what, and AI systems make that visibility problem worse because they can be built quickly and spread quietly. Inventory is the foundation for control because you cannot protect, monitor, or govern something you cannot name and describe. For AI systems, inventory is not only about a model file or a server because the risky parts include prompts, outputs, datasets, integrations, and third-party services that influence behavior. A strong inventory creates a shared, reliable map that helps teams avoid guesswork and helps leaders make consistent decisions. By the end, you should understand what counts as an AI asset, why inventories reduce risk, and how to structure inventory thinking so it stays useful over time. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. The first key idea is to define what an AI asset means in a governance program, because many beginners picture an asset as a physical device or a single software application. In AI security, an asset is any component that affects how the system behaves, what data it touches, and what impact it can have if something goes wrong. That includes models, meaning the learned component that produces outputs, but it also includes the surrounding system that delivers those outputs to users. It includes prompts, because prompts can contain sensitive information and can also influence the model's behavior in ways that matter for safety and compliance. It includes datasets used for training, tuning, testing, and operation, because data drives both capability and risk. It includes integrations and dependencies, such as external knowledge sources, vendor services, and internal systems the AI can access. Beginners should notice that this definition is intentionally broad, because narrow definitions create blind spots, and blind spots become incidents. A well-defined asset inventory acknowledges that AI risk is distributed across many parts, not contained in a single box. Inventory matters so much because it is the first step in making governance real and repeatable, rather than informal and reactive. If an organization cannot list its AI systems, it cannot enforce policies consistently, it cannot run meaningful risk tiering, and it cannot be confident that new obligations are applied to all relevant systems. Inventory also supports incident response, because when something goes wrong, you need to know what system was involved, what data it could access, and what other systems might be affected. Beginners often assume that security starts with controls like access restriction, but access restriction requires you to know what you are restricting and where it is used. Inventory is also an efficiency tool because it reduces duplicated work and prevents teams from solving the same problem in isolation. For example, if two teams are using the same vendor model, inventory can reveal that shared dependency and allow governance to manage it centrally. When exam questions ask how to prevent unmanaged AI use or how to build defensible oversight, inventory is often the hidden foundation behind the correct answer. A practical way to approach inventory is to treat it as a set of questions you can answer consistently for every AI asset. You want to know what the asset is, what it does, who owns it, where it runs, what data it touches, what outputs it produces, who uses it, and what dependencies it relies on. This sounds like a lot, but it becomes manageable when you recognize that these questions map to risk and accountability. What it is and what it does define the scope of behavior. Who owns it defines responsibility and escalation paths. Where it runs and who uses it define exposure and access needs. What data it touches defines confidentiality and compliance risk. What outputs it produces defines potential harm and misuse risk. What dependencies it relies on defines third-party and change risk. Beginners should see that inventory is not a one-time list of names. It is structured metadata that supports decision-making. When you collect the right metadata, the inventory becomes a tool that guides governance rather than a static spreadsheet nobody trusts. Models are often the first asset people think about, so it helps to understand what model inventory should capture at a governance level. A model inventory should include the model's purpose, its type, its version, and whether it is built internally or provided by a vendor. It should include the context in which the model is used, such as summarization, classification, recommendation, or decision support, because context drives impact. It should also include what constraints exist, such as whether it is allowed to access certain datasets or whether it is prohibited from being used for high-impact decisions. Beginners should understand that version is not a technical detail. It is governance evidence, because you cannot explain behavior or prove control if you do not know what version is running. Model inventory should also capture ownership, meaning who is responsible for monitoring model behavior, handling updates, and coordinating response if the model produces unsafe outputs. Another critical element is change history, even at a high level, because change affects risk and may trigger reassessment. When model inventory is strong, it supports both compliance and operational stability by making the model's identity and governance boundaries clear. Prompts are a unique AI asset category because they are both inputs and control signals, and beginners often overlook how risky they can be. Prompts can contain sensitive information, such as customer details, internal incident notes, contracts, or proprietary plans, and that makes prompts a data protection concern. Prompts can also shape what the model does, which makes them a behavior control concern, because small changes in prompts can change outputs dramatically. Some organizations also use reusable prompt templates or system instructions, and those templates become critical assets that should be inventoried because they define how the system behaves across many interactions. Beginners should also recognize that prompts can be stored, logged, or reused, depending on the tool and configuration, which means prompt handling has retention and evidence implications. Prompt inventory does not mean collecting every user prompt in a database, but it does mean understanding how prompts are handled, what categories of prompts exist, and what rules govern sensitive prompt content. It also means knowing where prompts flow, such as whether prompts are sent to external services or processed internally. When prompts are treated as assets, governance can set clear acceptable use expectations and monitor for risky patterns. Data is the asset category with the largest impact on both risk and compliance, so inventory must treat data across the full life cycle, not just as a single dataset. You may have training datasets, testing datasets, fine-tuning datasets, and operational data sources that feed the system during use. Each category has different risk, because training data influences what the model learns, testing data influences what you believe about safety, and operational data influences what the system can reveal in outputs. Data inventory should capture the source, the sensitivity classification, the permitted purpose, the retention expectations, and the access boundaries for each dataset. Beginners often assume that if data is internal, it is safe, but internal data can be highly sensitive, and the risk increases when data is combined across sources. Data inventory should also include provenance, meaning where the data came from and what rights or limitations apply, because compliance risk often hides in unclear origins. Another essential element is integrity expectations, meaning how the organization prevents tampering or accidental corruption of datasets, because corrupted data can create harmful model behavior. When data inventory is disciplined, it becomes possible to apply controls consistently and to prove conformity when asked what data was used and how it was protected. Outputs are sometimes ignored in inventory discussions, but for AI systems, outputs can be as risky as inputs, because outputs can contain sensitive information or can be used to make high-impact decisions. Output inventory at a governance level means understanding what types of outputs the system produces, where outputs are stored, and who can access them. For example, if outputs are stored in ticketing systems, shared documents, or customer records, the organization must treat those storage locations as part of the risk boundary. Outputs also matter for monitoring because unsafe outputs can signal misuse, drift, or data leakage. Beginners often think of output as temporary text on a screen, but outputs often become records that are copied, shared, and reused, which expands exposure. Output inventory should also capture whether outputs are labeled as generated content in contexts where transparency matters and whether there are review expectations before outputs are used externally. This is not about policing every sentence, It is about understanding where output flows and where harm could occur. When outputs are inventoried as part of the system, governance can set realistic rules for review, retention, and evidence. Dependencies are the hidden web that often determines whether an AI system is controllable or fragile, and inventory is where you make that web visible. A dependency can be an external vendor model, a hosted AI service, an external knowledge source, an internal database, an identity system, or a logging platform. Dependencies matter because changes in dependencies can change system behavior and risk, and because dependencies often define where data travels. For example, if an AI system depends on an external service, prompts and outputs may leave the organization's boundary, which triggers compliance and contract concerns. If an AI system depends on an internal database, the integration may create a pathway for sensitive data exposure if access is not controlled. Beginners should understand that dependency risk is not only about security breaches, it is also about reliability, availability, and unexpected behavior changes when services update. Inventory should therefore record what dependencies exist, who owns those dependencies, what agreements govern them, and what change notification expectations exist. When dependencies are visible, governance can manage third-party risk and can plan for continuity and incident response more effectively. Inventory also needs to capture relationships between assets, because risk often emerges from how assets connect rather than from a single asset in isolation. A model connected to sensitive data sources creates a different risk profile than the same model used only on public data. A prompt template that instructs the model to retrieve information from internal systems creates different exposure than a prompt template that only drafts generic text. A dependency on a vendor model that updates frequently creates different change control needs than a stable internal model. Beginners should see these relationships as the wiring of the system, because security is often about controlling connections and preventing unsafe pathways. Relationship mapping does not require complex diagrams to be useful, but it does require recording which datasets feed, which models, and where outputs are sent. This relationship view supports risk tiering because it helps identify high-impact combinations, such as high-sensitivity data combined with customer-facing output. It also supports investigations, because when an incident occurs, you can trace which assets and dependencies could be involved. A mature inventory treats assets as a network, not as isolated items. Keeping an inventory accurate is its own governance challenge, because inventories fail when they are treated as one-time projects. AI environments change, and inventory must change with them, or else it becomes untrusted and ignored. A disciplined approach ties inventory updates to intake processes for new systems, to change control for updates, and to periodic reviews that confirm ownership and data flows remain correct. Beginners should understand that inventory accuracy depends on clear ownership, meaning someone is responsible for updating records when a model is upgraded, a data source is added, or a tool is retired. It also depends on clear definitions, because people cannot record assets consistently if they disagree on what counts as a model, a prompt template, or a dependency. Another factor is usability, because if updating inventory is too slow or too confusing, teams will bypass it and the inventory will drift out of date. A mature program therefore designs inventory as part of normal workflow, not as extra paperwork. When inventory is maintained continuously, it becomes a reliable source of truth that supports governance decisions. From a compliance and evidence perspective, inventory is one of the strongest artifacts an organization can produce because it demonstrates visibility, accountability, and control. Regulators and contract partners often want to know what systems exist, what data is used, and what safeguards are in place, and inventory is where those answers begin. Inventory also supports proving conformity because it can show that systems are tracked, classified, and reviewed according to defined routines. For AI, inventory can also support transparency obligations because it helps the organization explain what systems exist and what purposes they serve. Beginners should recognize that defensibility is not only about having documents. It is about having a coherent structure where those documents are linked to the systems they govern. Inventory provides that structure by acting as the index to the program's evidence library. If an auditor asks for the impact assessment of a particular system, Inventory should tell you which assessment applies and where to find it. If a regulator asks what vendor services process personal data, inventory should help identify those dependencies quickly. When inventory supports these questions, the organization looks disciplined and credible. As we wrap up, inventorying AI assets is about creating visibility and structure across models, prompts, data, outputs, and dependencies so governance can be consistent and defensible. You define what counts as an asset broadly enough to avoid blind spots. Then capture structured metadata that supports accountability, risk assessment, and evidence. You treat models as versioned, own components, treat prompts as both data and behavior influencers, treat datasets as life cycle assets with provenance and classification, and treat outputs as risk-bearing artifacts with storage and sharing implications. You map dependencies because they define data movement and change risk, and you record relationships between assets because risk often lives in the connections. You keep inventory current by integrating updates into intake, change control, and periodic review routines, so the inventory remains trusted and useful. For a new learner, the key insight is that inventory is not an administrative chore. It is the foundation that makes every other control possible, because you cannot govern what you cannot see. When you can explain inventory this way, you are aligned with task 13 and ready to build on it with classification, governance checks, and data risk management in the episodes ahead.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit DailyCyber.News.